The question is to find the Fourier sine and cosine transform of t power m-1. Our function f of t is given t power m-1. Now the formula for Fourier sine transform is integral 0 to infinity f of t sine omega t dt. First we will find the sine transform of the function. For cos transform, you just have to replace this sine omega t with cos omega t, which will be in the second part. So let us substitute f of t in the formula 0 to infinity t power m-1 sine omega t dt. Now to solve this integral, we will change this sine omega t in terms of e power. Sine omega t equals to e power I omega t minus e power minus I omega t divided by 2i. This is a very important formula. Let us quickly see how it came. How can e power I theta be written? Cos theta plus I sin theta. Similarly, e power I omega t can be written as cos omega t plus I sin omega t, and e power minus omega t can be written as cos omega t minus I sin omega t. Now we have to subtract these both. Cos omega t will get cancelled, the minus will become plus, so it will be e power I omega t minus e power minus I omega t equals to 2i sine omega t. So we get a formula from here. Sine omega t equals to e power I omega t minus e power minus I omega t divided by 2i. So I'll just shift this part to the right. Now let us substitute this formula in this. 0 to infinity t power m-1. We will substitute sine omega t as e power I omega t minus e power minus I omega t divided by 2i. Let us take 1 by 2i outside. We can write this as two separate integrals. 0 to infinity t power m-1 e power I omega t minus 0 to infinity t power m-1 e power minus I omega t. So we are going to use gamma function. As you can see that these both terms seem to be of the form gamma function. You must remember that 0 to infinity t power m-1 into e power minus at dt equals to gamma m divided by a power m. This is a very important formula. So using this formula, we can write this expression in terms of gamma. First, let us just change a few things to make it look in this form. That is, this form has e power minus at, which matches exactly with this term. We have gotten e power minus at term where a is I omega. But this term does not have e power minus at. We can't directly see this term in this one. We can manipulate this term by writing minus of minus I omega t, and that way our a will be minus I omega, and that way we are getting e power minus at form. So this is our expression, right? I'll just write this in the form of the gamma function. This is our final expression. So this is our formula. We'll be now using this here. After using it, we will get 1 by 2i. In this first term, our a is minus I omega, right? So we will substitute that in the formula. So that will be gamma m divided by a power m, and in this case our a is minus I omega power m, minus, similarly in this term our a is I omega. Using the formula, it will become gamma m divided by a power m, which is I omega power m. That's it. Now there is one more trick. You must always remember that I equals to e power pi by 2i. How did this come? Now let us derive this as well. How can you write e power pi by 2i? It is cos pi by 2 plus I sin pi by 2, right? And cos pi by 2 is 0. So this becomes e power pi by 2i equals to I, because this term will be 0 and sin pi by 2 is 1. So if I equals to e power pi by 2i, then I power m will be e power pi by 2i power m, which is basically e power pi by 2mi. And we'll now substitute this into our expression. Let's take out omega power m common. Like I said, I power m is this. Similarly, minus I equals to e power minus pi by 2i. How did this come about? Basically, e power minus pi by 2i will be cos pi by 2 minus I sine pi by 2. Cos pi by 2 is 0, so what is left? Minus I, because sine pi by 2 is 1. Therefore, minus I equals to e power minus pi by 2i. Similarly, minus I power m will be e power minus pi by 2i power m, which is e power minus pi by 2mi. So now we know the equivalent for I power m and minus I power m. So let us substitute both of these into this. 1 upon 2i omega power m, and we will write gamma m divided by minus I power m, which we are substituting here, and I power m from here, which is e power pi by 2mi. Let's take gamma m common. So 2i omega power m, we can write this as pi by 2mi minus e power minus pi by 2mi. What does this remind us of? If you suppose remove this 2i and bring this 2i under this. Remember, just a few minutes ago I told you about this formula. Sine theta equals to e power I theta minus e power minus I theta divided by 2i, right? In this case, our theta is pi by 2m. So we can substitute this as sine of pi by 2m, which will be equal to e power pi by 2 mi minus e power minus pi by 2 mi divided by 2i. So let us substitute this whole thing as sine pi by 2 m. Okay? Gamma m divided by omega m power m into sine pi by 2m. That's it. This is the Fourier sine transform of our function. Alright, let's go to a new page and let's solve the cosine transform. Exact same way. The formula for cosine transform is 0 to infinity f of t cos omega t dt. F of t again. Let's substitute it in the formula. 0 to infinity t power m minus 1 into cos omega t dt. Just like the previous case, we will write cos omega t in the form of e power. Always remember, cos omega t is equal to e power I omega t plus e power minus I omega t divided by 2. Now I'll quickly tell you how it came. E power I omega t can be written as cos omega t plus I sine omega t, and e power minus I omega t can be written as cos omega t minus I sine omega t. Now we will add both of these equations. So this will get cancelled. E power I omega t plus e power minus I omega t will be equal to 2 cos omega t. So cos omega t equals to e power I omega t plus e power minus I omega t divided by 2. So now we will substitute it in this formula. T power m minus 1 e power I omega t plus e power minus I omega t divided by 2. Split it into two integrals, taking 1 by 2 outside. 0 to infinity t power m minus 1 into e power I omega t plus 0 to infinity t power m minus 1 into e power minus I omega t. Now we will use the same gamma formula. I'll write it down here. Again, I'll bring it to the form of the gamma function. T power m minus 1 e power minus of minus I omega t plus 0 to infinity t power m minus 1 e power minus I omega t. In this array is minus I omega, in this array is I omega. So we will substitute the formula gamma m divided by a, which is minus I omega power m, plus gamma m divided by a, which is I omega power m. Alright, now we have to substitute minus I power m and I power m, right? As I told you, I power m is equal to e power pi by 2 mi, and minus I power m equals to e power minus pi by 2 mi. I also told you how these both were derived in the previous part. If you still have a confusion, you can rewind the video and look at that part again. Let us substitute and take gamma m common, and omega power m can also be taken common, and we will get 1 upon e power minus pi by 2 mi plus 1 upon e power pi by 2 mi. Let's take 2 inside. So gamma m divided by omega power m, this can be written as e power pi by 2 mi plus e power minus pi by 2 mi divided by 2. Again, what does this formula remind us of? See, e power pi by 2 mi plus e power minus pi by 2 mi divided by 2 equals to cos of pi by 2 m. We just saw how this formula came. The general formula was cos theta equals to e power I theta plus e power minus I theta divided by 2. Let us substitute it here. So gamma m divided by omega power m into cos pi by 2 m. This is our cosine transform. Our final answers are sine transform we got omega m divided by omega power m sine pi by 2m, and our cosine transform we got gamma m divided by omega power m cos of pi by 2m. So I hope it was clear. That's all for today. See you in the next video. Bye.